This video is on formal charges, and we'll be covering what they are and what they're used for. So formal charge of an atom is the charge that an atom in a molecule would have if all the atoms had the same electronegativity. This is really just a technical term. Formal charges really help us determine the best structure when there is more than one possible Lewis structure for a molecule. Formal charges shouldn't be confused with oxidation numbers or ionic charges. They are slightly different. So formal charge can be calculated by taking the number of valence electrons on the free neutral atom. So for example, in oxygen we would have 6 valence electrons, and in nitrogen we would have 5 valence electrons. And we subtract the number of unshared electrons in the molecule plus half of the shared electrons in the molecule. And so the next question is, how do formal charges help us determine the best structure? And we really have two rules to follow, and they should be followed in this order. The first rule is that formal charges on atoms in the molecule should be as close to zero as possible. And the second rule is that negative formal charges should be on the most electronegative molecule. And a little side note, the sum of all the formal charges in a molecule should equal the charge of the molecule or the ion. So let's actually apply this. Example number 1, determine the preferred structure of OCN-. So here we have two Lewis structures of OCN-, structure 1 and structure 2. And so for structure 1, if we take the calculation for the formal charges of each atom, so the oxygen, the carbon, and the nitrogen, we would take the number of valence electrons in the neutral atom minus the number of unbonded electrons plus half of the number of bonded electrons. So if we do that, we would get oxygen would have a formal charge of 0, carbon, formal charge of 0, nitrogen, a formal charge of -1. Now this is actually looking pretty good to be the best structure. But if we do the calculations for structure 2, we get very similar numbers. Oxygen has a formal charge of -1, carbon has a formal charge of 0, and nitrogen has a formal charge of 0. So how do we, these numbers are looking about the same, so how do we determine which one is the preferred structure? Well, we go back to rule number 2, the second rule, and that is that negative formal charges should be on the most electronegative molecule. And so we have a negative charge on nitrogen in structure 1, and in structure 2, sorry, this right here should be a 2. In structure 2, we have a negative formal charge on oxygen. If we remember from periodicity, oxygen would be more electronegative than nitrogen. So structure 2 is the preferred structure. Okay, now example 2. Determine the preferred structure of PO43-. So first we want to draw the Lewis structures, and then we want to use the formula to basically calculate the formal charges. So here we have phosphorus has a formal charge of 1 and oxygen has a formal charge of -1. Now here there's something kind of special about it. Here we calculated for phosphorus and for oxygen, but here we have phosphorus, oxygen, and this oxygen actually has two bonds. It's a double bond, and here it's bonded by a single bond. So they are acting differently. So we're going to have to account for both of those, and we're going to kind of treat them as separate atoms. So when we calculate for oxygen with a single bond and oxygen with a double bond, and those will come out to different formal charges. So the formal charge for phosphorus will be -1. For oxygen with a single bond, it will be -1, and for oxygen with a double bond, it will be 0. And here we do have negative numbers, but we won't follow the second rule of looking at negatives being on the more electronegative atom, but we want to look at the first one, closest to 0. And here, structure 2, we only have, or in both of the structures, we only have one structure that has a formal charge of 0, and that's the oxygen with a double bond on here. So here we'll determine that this one, structure 2, is the preferred structure. Now one thing to note with this one, that little side note that I gave earlier, that all the formal charges added up should equal the charge of the molecule or the ion, we could see that here. So here we have phosphorus, 1, and we have 4 oxygens. So if we do 1 plus 4 times -1 will get -3. So that works. Here we have -1 plus -2 plus 0. So that's just -1 plus -2. That's -3. And that works out. So that wraps up this lesson on formal charges.